The whole thing started back in 2011 on La Réunion in the southern Indian Ocean, where I was at the NDAC symposium, and I noticed that nobody seemed to be very keen on using brewer data in NDAC. And with subsequent conversations, I discovered that they said, well, you haven't got a network. And after a little bit of puzzling, it became clear that, okay, we have a community, but we really didn't have a network which could be effective in harmonizing all the work we do in the different stations. So if you go to the next slide, please. So the cost action was basically conceived at that point, and we wrote the proposal over the period in 2012, and basically this is a brief synopsis of what we wish to do. And over the years, since the Vienna Convention and the Montreal Protocol, and a lot of science has gone into stratospheric ozone, so we do understand quite a lot about it. But there's still many things that we need to consider. We're still not quite sure what the future trends are going to be, and there's still things happen which we don't expect. And so what we really need to do is to bring some harmony into our operations. We'd like to have a coherent network of spectrophotometer stations and have a very consistent QA, QC system so that we've got an assured quality and basically a tier of quality assurance schemes, a hierarchy, if you like, depending on what kind of processing the data's gone through. So, for example, you take your raw data. If we want near real-time data, then the data that gets into the database as near real-time is going to be very close to the raw data with very little post-processing. At the other extreme, when you do your two-yearly calibrations with the brewer, then you can interpolate the results of the calibration, and that basically is the other extreme where the data is probably as good as it's going to get. And in between there may be various stages, and we need to flag that at what kind of quality the data is for the people that are going to use it. And we have not only ozone from the brewer, there are other products. We, as you've heard from Julian, we have UV products, and we can measure aerosol optical depth in the UV. Well, maybe more work needs to be done on that. There are NO2 measurements which can be done, which Henry Demos has done a lot of work on, done his PhD on. And there's sulfur dioxide. So there's many products that we can get from the brewer, and it would be nice if we can have a clear quality assurance scheme on as many of those as possible. Okay, do you want to, next slide? Time for a little bit of colour. This is a reminder of the ozone hole that we had in the Arctic in 2011. And you can see the extent of that and how it really did affect Europe. Norway got the brunt of it up there. And you can see that the levels don't actually come down to normal until we're right at the southern borders of Europe and the Mediterranean Sea there. So it was quite a significant event. Okay. This is a picture that Alberto put together for us, which we used in the presentation when we made the bid for the cost funding. And that shows all the stations in and around Europe where we have brewer spectrophotometers. So it makes it pretty obvious when you look at it like that what a massive resource we have there if we can use to work it properly as a network. And the background to that, the different colours, they are UV index, which the scale is on the left there, and they come from satellite data, but of course those are estimates based on radiative transfer models, where they have to input such things as cloud cover, aerosols, and they're at best probably I don't know, maybe 20% accurate, and they're really struggling when you've got polluted skies or cloudy skies. So one example of what we can do is if all the data we're collecting across that area is consistent, and we've got such a wide spread of different UV indexes, when the satellite data is produced, the predictions are made, we can then say, well, that's what you think you got, but this is what you actually got. And if we have a high degree of spatial consistency, then it becomes useful for feedback into the models. So that's one example of where we can make gains. Okay. So our research directions begin by looking at the characterization of the instruments. Within the Brewer spectrophotometer, there are many components. These components don't always work maybe the way you think they do. Such things as neutral density filter might not be quite neutral. It might have a wavelength dependence. So, for example, a problem with that is with my instruments, I take them to LNRCO to calibrate them, where we use a particular filter because of the brightness of the sun there. When I take it back to Manchester, we use a different filter. And so we're saying, well, if we don't know the characterization of the filters, then we could be losing the calibration in the process. So that's one of the reasons why we need to do it. There are many others as well. And then we need to standardize all the calibration protocols and data processing algorithms. We've seen in 2009 at a Brewer meeting a presentation where different processing algorithms on more or less the same data and looking at different instruments were giving different results. So we need to do everything the same way, so that if somebody takes a measurement in one part of Europe, it means the same thing as a measurement at the other part of Europe, and the data processing becomes standardized. And one of the advantages of that is that if we set up a central database and everybody sends their raw data to that database, we can do some processing centrally, and this allows us to pick out whether any particular stations are having a problem. We can compare with satellite data. If we see that most stations got a pretty good comparison and one stands out, then we can say, okay, you must have a problem. What can we do to help? Or if all the stations go wildly out with the satellite data, then we know it's a satellite that's a problem. And so one of the innovative things that we can do is the fact that we do have now because of the instrument's capabilities, we have co-located measurements of UV, ozone, and aerosol optical depth in the UV, and that's going to be the really useful thing. Although there's a lot of work to do to actually get the calibrations useful, especially with the aerosol optical depth. Next one, please. So these are the working groups. We have 4 working groups in the cost action. Working group 1 is to do with the characterization and calibration issues, which is led by Julian Grosvenor. And some of the tasks we have to address is to assess the potential for the internal components to cause problems, and then to develop methodologies to quantify them and to see how we can change the algorithms to deal with them. That's probably the main thing for that one. And in working group 2, which is led by Tommy Karppinen, we're going to be looking at the best algorithms to use, how to incorporate laboratory constants that we have, and other things. And in working group 3, this is a little bit more nebulous in that we're looking after the network governance. So we have to look at any practical problems which particular stations may have with implementing the network requirements. For example, we need calibration every 2 years on a brewer, and there may be some stations where it's not affordable. And so we have to see how we're going to deal with that, and how that fits into the quality assurance scheme. So they basically need to formulate a data version control which corresponds to the various quality layers of the data. Working Group 4 is basically the dissemination group, and that's led by Alkispace. And the idea for them is to work together with data end users to see what kind of formats they want, what kind of data they want, how they want it, how often they want it, how quickly they want it, and to feed that back into what we're doing with the database. Anybody from a cost country who has signed a memorandum of understanding can ask to join the working groups if they're interested in that kind of work. They can ask to join from non-cost countries if they're affiliated with the action, but that would be at their own expense. So, okay, future plans. We've begun to try and look at a site characterization record, which is coming under Working Group 3, Vela de Bock. And what we want to do there is just to get a list of all the sites that we've got, what the ancillary measurements are, and any other information which we think should be useful. And then we need to really get our teeth into looking at how things like stray light, these problems with the filters that I mentioned before, how they're affecting the measurements, and actually get some research done and some work in how we can deal with that. The calibration methods for the aerosol optical depth, these are going to cause big problems, I think, because the aerosol optical depth measurement is an absolute measurement, it's not a ratio. So we have to look at that quite carefully. And there's a challenge in doing that because we know that the European Space Agency are particularly interested in that data, and so we need to get stuck into doing something about it. And then the data processing algorithms, we need to decide how we're going to do the data processing, what we're going to use. We need to get all our heads together and say, this is what we do, and these are the best bits of it, or we don't want to do that, and then get something consistent. Error budgets, we need to know the limits of our uncertainties, and of course the database development, which will be started. It's already started, I believe, hasn't it, Alberto? Yep. We have funding for that already. So this has basically been what the cost action is about. So if we move on now, next slide, please. Here's a little bit of the mechanics of it. So anybody in a cost country can join the action. You do that by approaching your cost national coordinator. And because the action has been running for 12 months now, it will require a management committee approval, but that basically is just a formality if you're a cost country as far as we're concerned. The cost near neighbour countries can also join. North Africa, for instance, there is funding available for the near neighbour countries. If we don't have enough in the action budget that we already have, there is extra funding available for those people. We've got institutes from non-cost countries can join with the action, such as Tom McElroy from York University, Irina Petropavlovsky from NOAA in the USA, and Volodya from International Ozone Services. They've all joined the action as non-cost institutions, institutions from non-cost countries. The situation with them is that the cost funds can't fund them, so we have to find alternative methods for them to join in. And international organisations, in particular WMO, represented by Guy Bratton, and all the information you need to see if you want to join the action, how to do it, and everything else is at that web address there. And if there's any specific questions, I'm quite happy if you want to send an email to either myself or the Vice Chair, Alberto, and we'll see if we can answer whatever questions you have. Next slide, please. Okay, this is a very important thing which I think should be of interest to many of you here today, particularly those that have come along to the school. The short-term scientific missions are basically designed to further the work we need to do, but at the same time to get, in particular, early-stage researchers around to network and get involved with the projects. So typically, maybe somebody, an early-stage researcher from one institution, will ask to go to another institution where there may be a more experienced person, work together, make contacts, do some scientific work, maybe write a paper, and then they go back to their own institution afterwards with the increased knowledge. They've made the contacts, and people are getting to know each other, and the network expands. So the minimum period is a week, but we can go up to 3 months, where we can offer a grant of up to €2,500. There is a possibility of carrying out short-term scientific missions for a period of over 3 months, but that really is for early-stage researchers. In the other cases, as I say, you don't have to be an early-stage researcher to do an STSM, but if you want to do the over 3 months one, then I'm afraid you do, and that's defined as PhD plus 8 years. And again, if you want to apply to do an STSM, there's an online application at that web address, and you fill in a form online, and then you send a CV and a full scientific work plan to either myself or the STSM coordinator, who is Professor Anne Webb at the University of Manchester in the UK. And these are really good. I mean, these are really good opportunities for those that are new to the brewer and this kind of science, and just on the outset of your careers. They're really good opportunities, and I encourage you to think about it and take them up. The money's available. We're expected to do at least 4 every year. This year we've only managed 2. So, okay. And I still think that picture's cute. So if there are any questions on the cost action, STSMs, anything? Yes, Gaia.
Maybe you mentioned it kind of indirectly, but what about SOPs, standard operating procedures for the brewer instrument? This is something we have discussed about for a few years to develop so that the whole network will follow exactly the same procedures when they carry out the measurements and report the data and so on. So you talked a lot about different procedures and quality assurance, but what about really like a final product, a book that people can look up into and to follow the procedures?
Yeah, that would be a good idea, and that is one of the intentions as we develop the way we're going to do things, the way we're going to calibrate, the way we're going to characterize, and the way we're going to do the data processing. Yeah, to document it all. It will probably should end up online, so it's available to everybody. And in fact, as we run a network, obviously, if it's going to be a network, then it has to be a requirement that we work that way.
We have such handbooks for the Dobson and also for the ozone zones. So in the Go system, the only thing lacking now is a book like that also for the brewer.
Okay.
So there was a plan to use a short-term mission to go with Environmental Canada to write this, mainly the calibration procedure for that. But for the moment, Canada is not part of the transaction, so we cannot use all these facilities for that.
Well, York University is part of the action, and the NOAA in the USA is part of the action. The only one that isn't in Canada is Environment Canada. But hopefully, if we can get some dialogue going with Stoica, who I should have said, we're really grateful that Stoica from Environment Canada could come to join us today because of the obviously the historical involvement with this kind of work from Canada. I think it's very good that she's here, and I hope that we can get some good collaboration going and get to know each other a bit better.